let's get started gently on linear regression and indeed consider the setup for a linear regression, ignoring for a moment the survey design. And evidently, the survey design will come on the table very soon. So, suppose we're interested in the relationship of body mass index as an outcome variable on the two predictors, covariates, sex and age. Sex is binary, we need a single parameter. Age is going to be defined here as a 7-point ordinal variable. So the age has categories 1, 2, 3, 4, 5, 6, 7, depending on which decade you fall into, from 15 to 24, etc. Until then, penultimately we have from 65 to 75, and then more than 75. We construct dummies for each of the age categories so that we can use these dummies if needed. So, why dummies, by the way? Well, then we don't force a linear relationship onto age. We can really let every age category have its own effect. So the outcome Y is log body mass index. S stands for sex, 0 males, 1 females. And then A are the various dummies for a given subject of age. Of course, for a given subject, one and only one of the age variables is equal to 1, and all the other dummies are equal to 0, because you cannot simultaneously lie between 35 and 45 and between 45 and 55. As long as we know, people have one and only one age, of course. And then we have the error term. Usually, we assume the error to be either normally distributed, or if we take an ordinary least squares approach, where we don't fully specify the model, we would say the error has mean 0 and constant variance sigma square. Okay, good. So, that's conventional linear regression. In the design-based regression, we will bring in, just like before, corrections for stratification. So the estimators, and we will not spell out the details of the regression estimators under the various designs. We could do that, but that would fill another 7 or 8 chapters. That's not the idea. Just know that similarly to the corrections we apply to stratification, multi-stage sampling, for a mean, for a total, for a proportion, we can do the same with the regression coefficients. And then in the hierarchical model, we will introduce a random effect. Just as we saw before when we introduced the linear mixed model, the same here. You say, hey, wait a minute, now I have 2 or 3 or more levels in the hierarchy. We're illustrating it here only for the household versus individual level. So the addition in red is the BI, the random household effect. Okay.